I will have to say I'm not really a developer. I don't, I love to code but I don't do it day to day and all that. And I don't normally, at least in a few occasions, I've done some production level coding, but not generally. So, my code that you'll see will definitely not be of that quality, and I guarantee it doesn't. I didn't read the safety checklist before I wrote it, or do all that stuff. But anyway, so I work in consulting, healthcare informatics, and let's see, what's it doing? I'm a co-lead of a couple of work groups in HL7, vocabulary and orders and observations, co-chair, I should say, and co-lead on SNOMED on FHIR project, and so that's kind of a little bit about where I come from. So, okay, now we got something. So I was thinking about writing a couple more goals on there, but basically the main goal of this talk this morning is to hopefully stimulate probably your awareness first. Of course, you guys must be aware you wouldn't be showing up for this, but you must have some awareness. But and hopefully interest in the closure operation and what it, why is it there, and what may you and any of us be able to do with it that might help us with our applications. And I am not claiming any particularly special expertise in this, although I will tell you about a scenario where I've done something very similar, but that was long before anyone ever dreamed of FHIR, and it was actually in the early days of V3 and other things, but anyway, sort of ended up being kind of similar to what we're doing here with this operation. But anyway, so I think it has definitely utility, and I kind of put this tutorial together probably as much for me as I did for you guys to kind of stimulate my own interest in moving this forward, and to kind of teach myself a little more about how it's actually going to work in practice. And we just barely scratched the surface today, but anyway, I want to hear again why you're here and what you want to get out of it too as we go along. So, all right. So this, I have like 3 or 4 slides here about this, but so the first one is closure. Why would we need something like this? I guess I probably really haven't explained what it is yet, but this will give a background of of kind of the scenario that leads to it being something you might want to use. So if you're trying to do a query for FHIR observation resources for male patients over the age of 50 who attended some particular clinic within a certain period of time, a recent period, a couple of weeks, this example, with a particular diagnosis, in this case of gout, but also had another associated finding, example here, elevated serum creatinine. Some of that query would be based in terminology, and Peter talked about some things, and Jim has talked about searching similar kinds of searches, but some of it isn't really terminology based, and the question is sort of how do you make this all work together and make it work out. And so part of the terminology side of it, particularly if you're dealing with lots of data, is the need for closure, and that's probably more specifically called, you should think of it as transitive closure, because that's the more mathematical term for it, basically, where it's basically saying that I need a slide for this too to kind of show. We can actually show it maybe in the SNOMED browser here in a bit, but we need, where we traverse the hierarchy of relationships and we follow all the paths from a particular point to another point. We're basically we're trying to find all the paths, between, all the paths that are possible basically to traverse. And that's what a full transitive closure table does. But in this case, we're going to talk about maybe something a little bit shy of going that all the way there. So in this case, we had both the diagnosis of gout and the serum creatinine, and they involve value sets and some subsume queries, and that would be against both SNOMED CT and LOINC. And the idea of how you might want to do that, operationalize that on your client side, is you generate this subsumption closure table And you could do this on the fly. You don't have to necessarily, compute the entire SNOMED CT transitive closure table. I'm sure that Peter and others will tell you that it's really not very expensive to do that, and it may be actually the thing you want to do. And I'm not saying it isn't necessarily, but you are talking about a large number of rows in a database table, or however you're going to do it, or storing it in memory or whatever. And it takes a little time to compute. I think it's like, isn't it like, maybe Peter can correct me if I get the wrong number, but 8 million rows or something like that?
6.6.
Was it?
6.6.
6.6, yeah, so I wasn't too far off, but yeah, it's a lot. But anyway, so some architectural trade-offs there about which way you want to go. But what we could do, instead of doing that and maintaining it, we could generate more of an on-the-fly kind of table and base it on the kind of data that we're actually encountering. So this is kind of the idea of this operation is, basically we look at the data that's coming our way, and that data we need to care about, and we need to be able to determine, and I'll give you the scenario that kind of maybe fleshes out the need for that a little bit more here in a minute. But we don't necessarily need, every pathway that exists in SNOMED CT to do our decision support or something like that. So we might be able to be a little more parsimonious about it, and that's kind of what we're trying to do here. But basically what we do here is we use the terminology server to do the terminological reasoning, and then the server basically hands us the results of that, and we can use it locally to do the kinds of things that we need to be doing. So basically we do the closure table maintenance, and the server tells us what we should be putting in it. It's basically how it works. So in this case then, so for every new code encountered by the client and in some particular context, you ask the server what relationships exist within, with codes that are already in that context. And so maybe you've already encountered some data, and then you got new data, and you want to say, well, is there a relationship between these two things? And you can ask the terminology server about that, and it can tell you. And then, in case you encounter do those same kinds of comparisons again, which is a very common thing to do, you can have that that data locally, and you don't have to go hit the terminology server again, to find that out each time. So basically, you ask the server again for those relationships, and then you put them all in this closure table. And so it's basically it's a pretty simple table. It's a concept table, and you might have, depending on how you actually build it, you may have just a few fields, but you might probably need system and code, and maybe display. You don't really need that technically, but you might want it for readability. But you basically have a source concept and a destination concept, and you say these two things are, subtypes of each other. Peter used that word yesterday, as I recall, but something that's at a different level in the hierarchical, in the tree or the graph, basically. And so you'd be able to, but not necessarily a direct child or parent, which you could easily, get from just a straight relationship table. But you can build this table locally, and then you can include joins on it and use that as part of your other queries. And that's kind of why that was getting to that initial kind of multi-faceted scenario. You build those local caches of terminology and use those, maybe in your, maybe use a database query, to do that full search or something like that. So before I move on to the next slide, any questions or thoughts of anything I said so far? Hopefully I was at least reasonably coherent about it, but okay. Don't see any burning questions, so we can move on. So this slide is just to suggest that there are, certainly using the closure operation in FHIR isn't the only way to do some of the things that I'm talking about and want us to talk about. This is just an example of a few other things that I thought of, kind of more or less on the fly about what you might do. And I've already mentioned the full transitive closure table, which again, there's algorithms that, in the SNOMED literature, to do it for SNOMED, and it's a fairly straightforward thing to do, but it's it's a bit of, slightly expensive operation in some sense, although if you don't have to do it very often, it's not necessarily a big hit, but you have to keep it maintained and all that. And so it's something you'd have to consider, which gives you the most benefit, which approach to take. But you could also do something like just do hierarchical queries, and I'm thinking when I say that, mostly in the relational database world, but you can do similar things, in any kind of a world, in-memory databases, NoSQL or whatever techniques you might be using. But you can do hierarchical queries, which basically recursively, just iterate through the relationships table to get from one point to the next. And there are some actually fairly reasonable ways of doing that. That is how, in this personal thing, scenario that I'm going to tell you about, that's kind of how we started when I did that work. But Oracle, the big database manufacturer, has a pretty nice hierarchical query capability that you can leverage. It's outside of standard SQL 99, but it's their proprietary syntax, but it really works pretty slick. But it's still pretty expensive on a runtime basis, and ultimately probably isn't the way most people would want to go. You can also develop your own schemes of caching this stuff, or whatever you might think of to optimize performance. And there's a lot of different ways to do it, and I'm sure you may think of others. So if you do, please raise a hand, speak up, or whatever, and let me know if something we could add to the slide. So the personal scenario I was talking about was this. I was working for a startup software company in Utah, building out clinical decision support for infectious disease management. And I was the main, or almost the only developer on the terminology side of the architecture there. And we tried to figure out how we're going to, do this, and how we're going to build our inference engine and get our data feeds and kind of figure out how those things fit together. Because basically we were receiving loads of data from laboratories, mainly, again, we're talking microbiology here, so we're talking about culture data. We basically grow out a microorganism and identify it and do susceptibility testing on it to see what drugs will kill it and which ones won't, and all that. And all that data comes in from the labs over, in that case, it was HL7 version 2 feeds, and I'm pretty sure that most of the data is still flowing in version 2 feeds. That hasn't changed much. It's not, yeah. And but we had that data coded at, of course, a lot of it, particularly back at that time, wasn't directly coded because people hadn't really exactly heard all that much about LOINC and SNOMED at that time, So we had to kind of code it for them. But you code it at the level of the specificity of the data that you get, but when you're writing rules in an expert system, an inference engine, then you want to write them, at a little different level, and you got to figure out how to connect those two things. So, so the rules might be talking about pneumonia in disease space, or gram-negative rods in microbiology, but your instance data is going to be at a lower level, maybe specific kinds of pneumonia or particular microorganisms, and you need to see if your rules need to be triggered, based on that data. And so, you can use terminology, the knowledge that's built into SNOMED, particularly in the organism, area and in disease as well, to help you connect those kind of things. So terminology can play a pretty crucial role there, but you got to make that connection, and it's not, again, necessarily straightforward parent and child relationship. Maybe multiple levels involved. So, it's like I said, doing that can be kind of expensive. The full transitive closure table, as I said, is kind of big, and and also you have to keep it up and all that. And so we decided at the time when I was doing the work, we would build our closure table. We didn't even call it that, actually. I'm not sure if I even knew that name for it at the time, but I probably did. But I learned about it anyway. But when I first started, I don't think I did. But we ended up doing a kind of just-in-time transitive closure. So we basically see what data we got, then we'd, look at that and we would match it against the triggering concepts in our rules and see if there was a relationship between the two, and if so, then you could trigger a rule. And so you basically, we had our own built-in terminology server. We didn't have such things as FHIR Terminology Service then, but we had our own terminology API at that point, and we'd ask it, whether there was a relationship or not, and if it was, then for performance optimization, we would cache it, and we'd build that up over time, but it would never be, more than probably a few 100,000 rows at the most, probably less. And then when, if something changed in the code system, or if you did additional work, which, sometimes we would have to supplement SNOMED or whatever with some additional concepts, and every time you did that, you might have to recompute things, but you basically can start over with a small table, and it just kind of builds up on its own, and it's works pretty well, actually. So that's kind of what we did then. So basically that kind of strategy is pretty much what Sclosure is doing, and we'll take a look at the specific documentation on that in here in a second. But I wanted to mention some of the terminology servers, FHIR, specifically terminology servers. I just should have put the terminology word in there, but that support the Sclosure operation. Graham's server does, or at least it did. We found out that it wasn't working when I started to actually do the final preparations for this, and he's fixing it as we speak, I think, or was anyway a few hours ago. But we won't be able to show it. Well, we might be able to show it actually by the time of the Let's Build session, because I think it probably will be working by then. But anyway, things kind of come and go, in this world. But it was really the first one that did it. But the Onto server, from CSIRO in Australia also supports it, and that's the one we're going to be looking at here. And also the New Zealand server from Peter Jordan's put together, Termin server does it, and I believe the Fast server from France does as well. I have not tested that. But they say they do, and I wouldn't be surprised if they do, but I haven't checked it out. And there may be a few others, but there's a lot of terminology servers that don't do it, and I didn't list them, but the Happy server has terminology services, but it doesn't have Sclosure. And Vonk, I haven't really looked into Vonk that much, but I'm sure it doesn't. So those are probably the main ones to think about. Okay, so exploring further, basically we're going to take a look, through some of the documentation here, and then we will, kind of get, moving towards the Let's Build session after the break. So let me see how we are on time. We've got a little time left. Okay, so I think, that's all I've got really on the slides right now. So what I think I want to do, I bet that's Graham posting on Zoom up there, but I won't look at it right now. But let's see. I need to adjust the sizes of this a little bit. Actually, I need to get a different window. Sorry. There should be multiple tabs here. That's why I'm not quite sure why not. That's not it. Got too many windows open. So it should be, apologies for that. Yeah, I think, I'm sorry, I don't know where my window went, but that's okay. We'll do it without that. I think we can start with, where was I? It was that other one I was looking for. Anyway, I'll make this big and we will get going. I believe it's actually hidden in that other window. For some reason I can't see the menu bar. We'll just do this. Yeah, the menu bar kind of goes away for some reason when I make it big. I don't know why it's doing that. Well, sorry about that, but let me just maybe not make it quite so big, and maybe that'll work. I'll do it this way. I just want you to be able to see it. Okay, we'll open. Just open a new window, and that'd be easier. So make that bigger. All right, so let's go to the FHIR spec here. Okay. And I guess does that show up on the back okay, or do I need to bump it up a little bit? I can do a notch or two. All right. So let's go to FHIR R4 to start with, because I will say, I didn't put a slide for this, but there's going to be some changes to both the concept map resource and therefore the closure operation and the translate operation, which are all closely related. That's going to be changing, have some fairly significant changes for R5. So it's something you probably want to be aware of. We decided that there was some confusion about the way relationships were being described, and that's going to get altered, and I'll try to explain. We don't know exactly all the details of how it's going to end up landing, but we've made some simplifications on it already, and I can show those. So if I can do, sorry, let me get to, that's what I want. All right, so again, if you can see concept maps, this is where we start, basically. The concept map resource both provides the underpinnings for for most of what we're doing here. It provides the output of the closure operation. So we'll just take a quick look at the resource itself for a second. I do need to make that bigger. Okay. So I think the meat of it when you get down here to group, and again, I don't know how familiar everybody is with this. If you're all very familiar, you can tell me, and we can not spend too much time on this. But we basically declare source and target value sets that give us our context for how we're doing maps, and we basically specify. When we get into the element, then we specify the source concept, the code, and we can also give it a display. And then we have the mapping targets, with, again, code and display, and also a relationship, which is called equivalence in R4. And that's one thing it's going to change. It's going to be called relationship in R5. Because there was a determination that really all the relationships there weren't necessarily equivalence relationships, and we're also simplifying, the value set. So the current one, I'll just show you what's in here real quick. We've got a kind of a nested set of things. We start with related to at the top, and then there's the equivalent. There's also an equal below it, and that's it's hard to determine really necessarily what the difference is between those. Then we have wider and subsumes, and those are actually not that different either, and narrower and specializes. It's kind of esoteric to really make a clear distinction between them, and then there's some other things here that also can be a little confusing. So we've decided to kind of revamp that, and I'll show you the simpler version here in a moment. But anyway, that's this resource provides the output for closure. And so now let's go to the operations for a second. And so we'll hit closure first here. So again, I don't know how many of you have looked a lot at it, but basically it's pretty simple. There's only got just a very few input parameters. You have a name which you need to give, which basically defines a context. It's basically saying I want to build a closure table for something, whatever it is, that I'm working on, and I can give it a name. So at least I'll know what it is. It's not a coded thing or anything, but my application would probably recognize that name, so. And you could have multiple contexts and multiple closure tables built for those different contexts by giving them different unique names. So you give it the name, and then you provide concepts, and provide concepts in the form of a coding. It's not a codable concept with multiple codings, but it's a single coding, and that includes, of course, the code system and the code itself and the display if you want to use it. And then you also can supply a version. This is not the version of the code system or the code. It's the version of the actual output of the closure operation, the concept map. So, and there's some significance to that, which we'll see in a little bit. But the out parameter is only a single one, and that it returns a concept map, and it's basically a list of new entries, which code and system. Keep making it bigger here. That it's whatever the client should put in its closure table, and it also is restricted. This is a kind of an important point. When you get to how to use it, the only kind of equivalences or relationships that are returned would be the equal, specialized, subsumes, and unmatched. Now I think we're actually that's going to be even further simplified, but typically you're dealing with different levels in the hierarchy normally, so you're going to be talking about broader relationships and all of that. So or specialized, subsumes would be the right one here. But again, that terminology is going to get less confusing as we move into R5. So, but anyway, it doesn't have every possible relationship value that it returns. So anyway, that's that's how the resource and the operation looks. So basically, this is going to show that you basically make a request. In this case, you can give it the name. Here, in this case, patient problems, and you give it a concept with a system and a code, and then you get a response back, and that response back is a concept map resource, and it returns these basically the source and the target code and the equivalence relationship. Okay, so that's what it does, and then you basically take that output and then you figure out how you're going to use it locally, and that's the part I'm kind of leaving as an exercise for us to look at in the Let's Build session, where you can maybe take, if you want to use my little bit of code, you can kind of add to it, or you can use your own code or whatever, but then figure out how you would, what you'd want to do with this output and use locally. So you might put it in a relational database table, or an in-memory database, or whatever you might want to do, or just a text file even you could probably, or whatever might work for you. But you can make it work for your local needs. So you could put it in a JavaScript array, or a lot of different things you could do with it really. But so anyway, I'm curious if folks have this makes any. I guess does this make any sense? What I'm saying so far. Does it raise any particular questions? Do you have any additional ideas that you've thought of how you would maybe architect things with using this, or are you just completely glazed over and tired from last night? Peter.
Could you clarify which direction the equivalence relationship goes in?
Yeah.
I know there's been discussion about.
There's been that's been a big part of the discussion. So that's a good question. So the way the specification, we could go look at it, but I'll just tell you, nutshell what it says. Basically, the relationship is from source to target, because that's how we basically deal with all kinds of relationships. So we start with the source code, and then we compare it with the target code. But the way that the codes are written assumes that the target code, is what is of interest to you. That's the thing. I'm again in this operation. I'm getting back this set of new target codes. I already gave you a source code, and it was, and now I want to find these new target codes that it has relationships with. And so I describe, if I say subsumes here for the target, that means that the target subsumes the source. Okay, so you got, this is the source code, and this is the target code. And so the problem that people had with that is that we say that the relationship is source to target, but we describe it based on the target as compared to the source. So that's a bit of a sleight of hand thing, so yeah. So we're going to try to change that, but the only way to do that is essentially reverse the meaning of the codes that were there before, which is kind of a nightmare. I see Dan putting his hands on his face, and I agree. Yeah, right. So I think what we will end up deciding, it hasn't been actually decided yet, but see, we got I think 5 minutes maybe. Then we will probably change the codes and make it more explicit. Hopefully not too terribly wordy, but something like has broader concept, or because we're going to go, instead of having this kind of fancy subsumes and stuff like that, we're going to just talk about broader and narrower, when we get to the new version. And we'll try to make it clear that it's which way it's going, so it's a lot less confusing for people. But that wasn't really the main thing we're here to talk about today. But so let's see. What I can do now is we could kind of take a look at some examples of how this kind of works out. And, oh, there, clicking on the wrong spot. I've got the Postman REST tool open here with some queries on it. It looks like I think I can make those bigger. Okay. So I've got a few pre-done queries, which you also have in your exercise sheet. And we can start with it here and just kind of watch what happens. So we start, which really it's a simple operation. We basically post to the server base. It's a concept map based operation, but we don't post to the concept map endpoint. I'm not sure I can totally explain to you why that was decided, but it was, and that's how it works. It doesn't seem like a bad thing to do, but it seems a little bit arbitrary to me, actually, why it was done that way, but that is the way it is. And so again, post to the base server endpoint, and it is a post. You can do some gets like to pass the parameters, but if you have to pass the codings and all that, basically you need to be posting a parameters resource to make it all work. So and that's what we'll see here. Again, hopefully you can see this well enough. So this is how we start out with it. We start out by passing a parameters resource or posting it with a single parameter, which is the name. And so again, this is a little confusing. We've got name here twice, but that's because name is the element in the parameters resource, and name is the parameter in the operation that we're trying to use. So we have to, basically it's the same word in both places. But then the value string of name is going to be, in this case, I just chose an arbitrary name, test closure. So if I post that establishes a new context for building a closure table. And so we can do that. And again, we're going against Onto server, and it's in Australia. I don't know if we're seeing it from there, but let's see if I can pull that up and get it so you can see it. Yeah, maybe that'll work. So this is what's returned. It's a very simple concept map resource, which doesn't have a whole lot in it. It basically repeats the name. In this case, you get a status and experimental. Not every server has to return exactly the same elements in these things and a date. It doesn't have anything else. It doesn't have any relationships because we didn't give it anything to check yet. We just initialized the table. So basically, we have an empty table at this point, empty closure table. So the next thing we come along and do, let's see how we're doing on time. We're about out, but and we carry on with this after the break. But so we'll flesh it out a little bit. We basically post the same, string, every time. There's really not anything really much to vary, but what varies is the payload in the body. So we've got, again, a parameters resource. We still have the same name because we have to keep the context, and then this time we're passing in a concept, a code here. So we have it's the concept parameter. It's a value coding. And it's got a system and a code. So it's a SNOMED. We're going to be using SNOMED here. It's the best for demonstrating hierarchical, relationships and terminology that we have, I would say. But we're going to give it that code, pass it in, and let's see what we get back. So we get back something that looked just like what we got back before, basically. That doesn't seem too exciting. About the only thing, I think the only thing that's different, other than I guess the date stamp is a little bit different, but it's the version 2 now instead of 1. And again, that's just keeping track of what's the version of the concept map resource. It's building the closure table. And we don't get anything else. And the reason we don't get anything else is because you don't have anything. Again, we only got one code in there now, so there's nothing that it can relate to. It can't check the hierarchy to see if there's any relationships between these things. So we haven't, because it only has one. So we can go ahead and do the next one, I think, and then we'll probably need to take our break here. At least I can. Is that at 9:40 is when we're supposed to stop?
Yeah, a couple of minutes.
Yeah, okay. All right. So now we do basically the same thing, but I'm going to give it a different SNOMED code here. And so everything else remains the same. Let's go ahead and post that and see what we get back. Okay. So now we get a little bit more, and this is what it looks like. So we get, again, the same metadata. Now we get some actual output. We get a group, and we saw that earlier when we looked at the resource. It tells us what our source, source concepts, where they come from, in the version, and the targets, basically what we're getting and what it's being mapped to, and what we're starting with and what it's mapped to. And then, the real meat of it's in the element here. So we have basically our original code, and then, we're basically saying there is a relationship between these two codes, and it's a subsumes relationship. And again, really, the subsumes, or what's going to become a broader or narrower relationship, depending on which direction we go with it. But in the new version, is really only one of real interest here. But so this says there's a relationship between these two codes, and so we'll build out more from there. I think probably it's time to stop for now and take our break. And if you have any questions, you can go ahead and ask those now.
Does that use the equivalence relationship from concept map, or does that use the equivalence, the value set for the $subsumes uses? I don't think it uses the concept map equivalence relationships. I think it uses the $subsumes equivalence
I don't
relationship.
think they're different.
Well, so with $subsumes, you can only get 4 values back. You can get subsumed,
Right.
subsumed by
Right.
equivalent, or not subsumed.
Correct.
And I think that's what you get back from Sclosure.
Well, that's basically right, but it's all based on that same, code system and value set. So, it's all they're supposed to be. I mean, they have the same meaning. So.
They have the same meaning.
Yeah.
I think it's a different code system.
Yeah, we can find out. I didn't think it was, but you could be right. I'm not saying you're not, because you probably know. But anyway, that's a good question. We can answer that when we come back from the break. So, all right. So, see you in a few minutes.